My name is Jifei Ou. I'm from the MIT Media Lab Tangible Media Group. And for this student symposium, I presented one of my PhD research, which is looking at how to use 3D printing as a method to create fine hair structures. So the whole project actually begins with this inspiration in the nature world that where we can see this kind of like a hair structure occurs at a different length scale, and at a different length scale, they all have different functions. And of course, one of them is definitely they're very beautiful. So coming from the design background, one of the initial goal is that how can we use the advanced manufacturing technology to capture those kind of like fine structures. And so as I start that, basically, in order to make this project happen, we have to develop, like a new computational model and new fabrication pipeline in order to really achieve like all this engineering effort in order to achieve the structure that we want. And then in the end, we did can basically print the super dense fine hair structure at 50 micron resolution, which is exactly the diameter of the human hair. And once we are able to do that, we start to explore what kind of other utilitarian functions the hair can bring. Some of the example that we have is the hair can become a very effective mechanical adhesion surface where you put two hair structure together. They can basically lock together and very hard to peel it off. It's kind of like a Velcro, but not exactly like a Velcro structure. And the other thing we've been working on is also we discovered that with the hair structure, if you design them in a specific direction and geometry, they will be able to resonate to a certain frequency, and therefore you can use the hair as an actuator. So basically, it can take a different vibration frequency and make that into different movement, for example, rotation or linear translation, this kind of different movement. So the idea is how can we use that as a alternative way of thinking about, if we design robotics, all the thing that is moving, how can we use that this hair structure as an effective way of converting the random vibration energy into useful movement. And then the last but not least is we also discover that again, when you have the hair arranged in a specific direction and the geometry, and you can turn the hair into a passive sensor, which means that by combining this with a microphone, you can the hair can basically tell when you swipe on it, it can tell which direction you are swiping and also what's the speed you are swiping. So basically, through that, you turn the hair into an effective sensor. So this is a whole, almost we start with a design idea, but then it ends up become a lot of different engineering application, and then they all have they all have this kind of potential to be used in the engineering world. And while I'm basically showing this kind of different engineering applications, there are also a lot of feedback from a fashion world, and because they were saying hey Jifei, this is a really interesting invention because okay, we have real fur, we have fake fur, but now this is a way that first time the designer can manipulate the hair structure at each strand of the hair, at the scale of that really opens up the possibility for designers. So right now I'm working with a fashion designer to look at how can we use this new technology to rethink about the future of the fur garment. Can we design a garment that can basically slowly gradient from a fur to scale or from a fur to feather, this kind of a concept like that. So for my thesis, basically, I'm looking at, it's so if we think about a spectrum, right, it's we can think of nowadays, we have a lot of more and more material scientists developing engineered material that is so small at a nanoscale that people cannot perceive. And then we also have, but then as a designer, basically we still operate at the human scale, which is something people can see and directly manipulate. So for my thesis, I'm looking at how can we, how can you design a method, how can you design a new design methodology to bring these two worlds together at a specific length scale. So for that, I presented this kind of printing hair structures. I also worked with my colleague on another project, which is looking at how can you print a live bacteria on the garment. So this bacteria is hygromorphic, which means that they will swell and shrink based on the environmental humidity. So when we print this on the garment, so basically we design this kind of like almost like a running suit that has a lot of like a window opening on your back. So when you run, start to sweat, this bacteria will swell, make the flap open, so for your skin to better breathe and cool down. And then when it's cool down, when your skin is dry, and the bacteria will shrink, and then therefore making the making the flap flat again, and therefore keep your body temperature constant. Another thing I've been working on these days is like how can we create millimeter scale air pouches. So when you inflate these air pouches, super small air pouches, you can get the fabric again to fold and to become flat. So the idea is how can we use that to rethink about future of packaging, which is again a lot of designers have been working on. But then it's looking at how you can use new technology to rethink and reinvent design.